All right, Honors Algebra 2, welcome to the final video here in your 1-4 to 1-6 game plan. What we're going to do is talk about section 1.6, and I actually want us to go to the preview to section 1.6, which is on page 11. Page 11 here, preview to 1.6. Previous video, I did some of these. I just want to finish these up with you. I'm just going to do them here. So let me talk about number 4. So we'll graph something like this soon in this video. So x can be less than or equal to -9 or bigger than 1. Well, that is an or statement because there is no number that is both less than or equal to -9 or greater than 1. So it can be 1 and anything bigger than that, so 1 to infinity. Notice there is no equality part there. Or, big union, I should have gone left to right here. But less than or equal to -9 means -9 is, remember we go low to high, is the highest it can be. And then the lowest it can be is going towards -infinity. So -infinity to -9, union 1 to infinity. We are going to write things like that a lot in calculus. So just have that down. That's what this means. We'll need it, and you'll need it next year. You'll need it in calculus as well. So let's talk about here. Number 5. Greater than 0 just means 0 to infinity, towards infinity. I use a parenthesis because it can't be 0. There's no equality part there. All right, and judging by this, I think I just need to do 10 with you. All right, so we have this graph, all right, on 10. Anything -2 or below -2, anything 6 or more. So again, -infinity to -2, parenthesis around -2. Union from 6 to infinity. All right. -2 or less. No, I'm sorry, less than -2 or 6 and above. Or U for union. All right, again, don't fret too much over those. We did 1 through 4 in class on this page, so let's talk about this next page. Page 13, let's just continue it to the end here. On 13, I think it's important that we talk about 5 here. So some of these are on the easier side. Number 5. 5 says 4x greater than or equal to -8. So divide both sides by 4. X is greater than or equal to -2. Or divide by -3 here. X, -7 less than or equal to, flip that sign. X is less than or equal to -7. So can you think of a number that is bigger than -2, greater than or equal to -2, and less than or equal to -7? You cannot. They go in different directions. So here is the greater than or equal to -2. It's going in this direction. Okay. Here is the less than or equal to -7 part. It's going in this direction. Oh, sorry, that's bad. All right, anyway, can't be both. No number fits in both there, okay? So let's then talk about number 6. So x minus 6 greater than -11. Add 6 to both sides. X is greater than -5. Subtract 5 both sides. 2x less than -10. Divide by 2. X is less than -10. So, can you be both bigger than -5 and less than -10? You cannot. Here's -5, here's -10, and we would be going opposite directions. Greater than means I shade to the right, open circle, because there's no equality. Less than means I shade to the left, open circle, because there's no equality. All right, so just like the previous page, that's what we're talking about there. Now, either if you're in A group today, or if you're in B tomorrow, we did ones like 7. That's page 12. So in a 7 here, add 3 to both sides. I'm sorry, all regions, all 3 regions. -6 is less than or equal to 4x, which is less than or equal to 16. Divide by 4. Ooh. All right. So -1.5 or -3/2 less than or equal to x, which is less than or equal to 4. All right. So here's -3/2. There's 4. Less than or equal to, less than or equal to. This is an in-betweener because x, you can think of a few numbers, greater than or equal to -3/2 and less than or equal to 4, literally all those numbers. 0, 1, 2, 3, -1. All work. All right, so let's go to page 14. Now for everyone, if you're watching this video on Monday, the last day of August, this is all relatively new. Well, let's talk about 12 here. Absolute value. So first off in the absolute value, 8x plus 3 less than or equal to 4. So this is saying you have to live within 4 miles of some destination, the tracks. So I could live at 4 and closer. Or because you could live to the left of the tracks, you could live at -4. And what I've done is I've literally multiplied an inequality by a negative. So I could live at -4 and closer, which means it's greater than, oh, I forgot the plus 3. Greater than or equal to -4. And again, just like any absolute value, 4 to the right, 4 to the left. Well, if I have -4, this has been multiplied by a negative here. So greater than or equal to, okay? The sign flips, very important. You guys remember that from Algebra 1. Subtract 3. Again, it's exactly what comes out of the absolute value. It's 8x plus 3. 8x plus 3 in both. Equals right side of the tracks or the left side. So 8x less than or equal to 1. X is less than or equal to 1/8. Then we have 8x greater than or equal to -7. X is greater than or equal to -7/8. Now you can leave your answer like that, but when you get into calc, you're going to write it kind of in an interval notation, definitely an interval notation. So you need to ask yourself, can you think of a number that is greater than or equal to -7/8 and less than or equal to 1/8? You can. 0 fits that. So you could write your answer like this. And that is a fine place to start in calculus because you have equality, bracket around -7/8 to 1/8, bracket around 1/8 too. That is the ultimate answer there. In 2 years, this is on the first homework sets. All right, so that's a good one to talk about. Let's talk about number 13 as well. Again, when you need to pause this. Okay, on this one, 13 here, 5x minus 4 greater than or equal to 12. 5x minus 4, I could live 12 to the left, multiply inequality by a negative. So this is saying that you have to live at, that doesn't need to be that big. You have to live at least 12 away from some site, some place. So I could live here and to the right, greater than or equal to 12, exactly what I see. Or I could live at -12 and anywhere that way. And that is represented as less than or equal to -12. So graphically, you can see why that works as well. Add 4 to both sides in both inequalities and then divide by 5. X greater than or equal to 3.2. Add 4 to both sides. X is less than or equal to -8/5. Can you think of a number that's greater than or equal to 3.2 but less than or equal to -1.6? You cannot. So that would be the -infinity to this union this to infinity. So we won't touch that this year, okay? Next year for sure, and in calculus for sure, be ready for that. All right, have that down. 14 is similar. And then 15 and 16 are kind of the same, though 15 is easier. All right, so that is one for class. Let's talk about 16. I'm going to add 8 to both sides. All right, so 2 times this absolute value is greater than 8. Divide by 2. 1 minus x is greater than 4. Okay, so I got to live 4 to the right and continue to the right, or 4 to the left and continuing to the left, because I got to be more than 4 away from some 0. So drop the absolute value, write what you see. Or here, 1 minus x is less than negative 4. 4 becomes negative 4. Inequality, think of it as multiplying by negative, so the inequality sign flips. Subtract 1, then divide by negative 1. You flip that sign. X is less than negative 3. Subtract 1, divide by negative 1. X is greater than 5. Can you think of a number that's greater than 5 and less than negative 3? You cannot, so this would definitely be an OR statement. Negative infinity, negative 3, union 5 to infinity is how you're going to write it in 2 years. All right, folks, everything else we should do in class for the notes. Let's go to the last few pages here in the hashtag game time section. How about we start off with a real easy one, number 1. Number 1. Got to get x in the middle, so I'm going to subtract 6 in all 3 regions, and that is literally my answer. X is between negative 9 and 5, and not including negative 9 and 5. It would be the barbell with 2 open circles type graph. How about we look at 5 and 7 on this page? Number 5. All right, 2x minus 3 greater than or equal to 9. 2x minus 3 less than or equal to negative 9. Add 3 to both sides. 2x greater than or equal to 12. 2x less than or equal to negative 6. Divide both sides by 2. Greater than or equal to 6. Less than or equal to negative 3. Again, there's no number greater than or equal to 6, but less than or equal to negative 3. That can't happen. That is an OR statement there. Or can't find a number that fits both. All right. Then we'll do 7 together. 7's a little interesting looking. Not too bad there. I believe after that we have 1 left on the very last page. Then we will be in good shape to turn this in either on Thursday or Friday. So on this next one, let's add 4 to both sides. 1/2 x plus 3 less than or equal to 12. Divide both sides by 1/2, multiply by 2. X plus 3 in the absolute value is less than or equal to 24. All right. Might be able to tell what type of, if we're going to have a, an and or an or answer type of deal here eventually. So x is less than or equal, x plus 3 is less than or equal to 24. X plus 3, negative 24 is involved, greater than or equal to. So x is less than or equal to 21. X is greater than or equal to negative 27. Do you know numbers that are less than or equal to 21? Greater than or equal to negative 27? You do. There's a lot of them. So you could write your answer like this. In calculus, you go negative 27, negative 21. Again, this is all future. You just need this year, but this is good stuff to know when I teach you again. Good stuff to know for when I teach you again. All right, I'm going to move on to different screens, so pause this if you need to. And well, no, we got 2 more pages here, so a little too quick there. I want to talk about number 12 with you. Number 12. Add 8 to both sides. 6 times the absolute value, 4x plus 2 is less than 42. Divide both sides by 6. 4x plus 2 and the absolute value is less than 7. And then from there, go team. We can flip that sign, solve them both. Okay, get some fractions, no big deal. I think you can see what we're going to do on both sides in 14. On 13, one more like that. Add 6, divide by 3. On 13, add 6. Divide by 3. 2x minus 4, and the absolute value is greater than 6. 2x minus 4 greater than 6. 2x minus 4 less than negative 6. And then solve both. I think you get x is greater than 5. X is less than negative 1. Arrow means continue on. And folks, doing a great job. Let's talk about getting one started on the last page. Should have done 3, 4, and 5 with you in class. And we will be in good shape to turn this in by the end of the week. Okay. Multiply everything by 6. Both sides get multiplied by 6. 5x minus 2 in the absolute value, greater than 30. 5x minus 2 greater than 30. 5x minus 2 less than negative 30. Add 2 to both sides, divide by 5. You get some okay decimals there. And folks, that concludes Honors Algebra 2, your 1-4 to 1-6 game plan. This is Yak Math Video signing out.